we are delighted to welcome Annabella Oliveira, a distinguished researcher with over 15 years of experience in forecasting coastal dynamics. Her interdisciplinary work integrates computer science and coastal engineering to develop tools tailored to stakeholders' needs in areas such as flood early warning, emergency response to continental event, and assessment of climate change impact on coastal region. For the past 7 years, Annabella has led the development and application of OPENCoastS, an open source on-demand forecasting service used across multiple continents. This work led to the creation of the coastal digital twin concept, which she introduced in her advanced research thesis. Throughout her career, Annabella has contributed to over 50 international and national research projects focusing on coastal dynamic modeling and forecasting. Her scholar output include more than 70 publications indexed by the Institute for Science Information, ISI, reflecting on H index of 25, underscoring her significant impact in the field. Thank you, and I hope you find today's webinar informative and engaging. Now let's welcome Annabella. The floor is yours.
Well, thank you so much, Xin. And I'd like also to thank EGI for inviting me to talk about what we have been doing in the past 7 years, bringing coastal forecasting to the hands of the users. So trying to make it simple to build and simple to use. I'd like also to say that this is not just my work. There's a team of people working with me, both from the information technology area and also from the estuaries and coastal zones division of LNEC. Next, please. Okay, you can, yeah, do it all through the slide. Okay, perfect. Okay, so we'll start with some context why coastal forecasts are important, why we need them, and what they entail in terms of technology to operate every day. Then I'll motivate why we need to look at coastal forecasting as a service, and also the opportunity that federated resources like
Sorry, I lost you.
Can you hear me?
I can hear you
now.
now.
Yes.
Oh, okay.
Now, yes.
Okay. Oh, by the way, I had a problem here. We had a major storm in Portugal, and I'm speaking through my phone. I hope you can hear me well, and I apologize for that.
No
okay,
problem.
then we're going to talk about OPENCoastS as a building block, a fundamental building block to build coastal digital twins and all the services they provide. And for that, I'm going to give you an example on how that can be built through our Connect project. I then wrap up with some of the challenges ahead, where we are heading, and what is out there to help us reach that. Next, please. Okay, so just a quick overview. What are forecast systems for the coast? It is exactly the same thing that we have for the atmosphere. So we run a prediction simulation with high accuracy, typically process-based models, forced by boundary conditions from the atmosphere, from the ocean, and from the rivers. In order for forecast systems to be reliable and able to support the management, we need them to be continuously validated with real-time or near real-time data. And that's a very important issue that I also always like to bring in, because there are many forecast systems out there that don't have the data layer, and the data layer is fundamental for the users to have trust in the products. Another aspect that sometimes people forget about forecast systems because they are short-term tools is that the database that we build with the forecast simulations every day can give us a very good perspective and knowledge over the behavior of our coastal systems. So they build very important and very rich databases of information. Now that's the nice part. Let's talk about the headaches. Okay, forecast systems require computer resources every day to run because they are a chain of simulations, and we have one run running on the top of the predictions from the day before. So we need to make sure that the computer resources are there for the computation and for the storage. The second aspect is that although there are many models out there, forecast systems require not only very accurate models, but also very robust models, because again, since this is a chain of simulations, the model cannot blow up. So in our particular case, we use the Schism modeling suite, which is very accurate and at the same time is very, very robust. Now, the other issue about forecast systems, they are quite complex in terms of information technology. It's not just having the model and making it run. We need to make sure that the implementation of the framework is adequate for all cases that we want to run. So that led people to develop forecast systems in the past on a case-by-case situation. So that was very good because they were very tailored to the specific site, but at the same time, they require a lot of maintenance in order for the model to be updated, in order for the information technology framework to be updated. And that limits the capacity to escalate forecast systems. Next, please. So now let me go a little bit back to the context. So what are the coastal community societal needs? We have needs for the short term. So we need to anticipate hazardous events and support emergency. And this year was a very good example of the importance of forecast systems. But forecast systems are also important to support all the water economy daily tasks, like supporting dredging interventions, supporting interventions in ports. So having a forecast system can guide and make sure that the interventions are well conducted and in security. At the same time, we need to look at forecast systems also from a long-term perspective, as the simulations every day build the said database of knowledge that we can use to anticipate the impact of climate change and human-driven interventions. At the same time, they can be very good harmonizing tools to address conflicting uses in coastal areas. Next, please. So, in very concrete ways, what are the problems that we want to tackle with forecast system? So the core ones, the short-term threats, include problems like flooding during extreme events, storm surges, river floods, urban floods, problems of coastal erosion that have a lot of significance in terms of destruction of land and assets, and also accidents related to pollution events. And that can cause a lot of impact, not only in the economy, but also in the ecosystems. We also can use forecast systems to look at long-term threats like sea level rise, rising temperatures, or salinity intrusion. You can always say, okay, but the forecast system runs a specific configuration. Yes, but if we use forecast systems together with data, we can make our forecast system evolve in time and being able to use it to gain knowledge on the evolution of our coastal systems. At the same time, forecast systems can help us to address European directives. Typically, the compliance to European directives is based on data, but as the directives become more stringent and demanding, having a forecast system can help the entities in charge of implementing these directives to, for instance, define what are the best places to implement an enhanced monitoring network. So there's a lot of work that forecast systems can also help us there. Next, please. Okay, so Now we have forecast systems. We are able to anticipate a lot of important stuff with a lot of high resolution information in space and time. Our forecast system can also be used not only to the real world, but also to support what-if scenarios. So we can build a new marina virtually in a digital way and see how it is going to impact our system. However, like I said before, they are very complex to maintain and improve. So that brought us to the notion of building an on-demand forecasting as a service. And in order to do that, we are able to centralize the development, execution, and the maintenance of forecast systems. Every time we make an improvement or an update in our system, all forecast systems get it. And at the same time, by having this centralized approach, we are able to explore federated computational resources. And that is very important for the delivery of the service in a robust and reliable way. EGI resources are an example of those federated access. Also, we wanted to make forecast building closer to the user. So we built the notion of on-demand service. Next, please. So OPENCoastS, our on-demand forecast builder, can create and maintain operational forecasting for the area selected user, because the users are those that create the forecast systems. And in order to do that, we have built a service that covers the whole forecast cycle. So we are able to generate the computational grid to run the model through the interface, configure the forecast in the way the user wants it, then manage our multiple forecasts, start it, stop it, and even clone it. So making, for instance, an analysis of sensitivity, for instance, for the friction coefficient, it can be done like for 10 different runs in something like 15 minutes. So it's very, very efficient. And we also have a very simple viewer, so the user can look at the results, download it, etc. And on top of this, in order for this part to be a service, and this is open for everyone to use it, we have an automatic assignment of the necessary computational resources to EGI resources. So we have the 4 parts of OPENCoastS. I have here on the screen the first of them, the grid generation, and all of this is built in the notion of a sequence of dashboards that the users just have to introduce very simple information. And you can build, you have an example here on the screen, very detailed computational grids using OCS Mesh and Jigsaw as the generation engines. Next, please. Okay, now a look at the configuration assistant. I'm not going to spend a lot of time in there. You can then, after the talk, register to access the service and give it yourself a try. But just to have your notion of the way it is organized. So it's based on the main building blocks of a forecast system. And there the user have a lot of options available, taking advantage of the connections that the system builds automatically with, for instance, atmospheric forcing conditions provider. We have Meteo Galicia, Meteo France, GFS, and also the Portuguese provider. Like I said before, no forecast systems without data. And there we have the ability to make automatic comparisons with embodiment stations, and the user selects which stations he or she wants to use for their forecast. And we also have a connection with Sentinel-2 images for the inundation part. Next, please. Okay, here is an overview of the manager. So we have several deployments running, and we have all the information regarding those deployments. You can see if it's running well or not, if something went wrong and there was an error. And you also have a lot of services they can do on the right part of the screen. You can check the status, clone, like I said before. You can duplicate your forecast with a simple click. And then you can start, stop, and do all the actions that we need to make sure that we just keep the forecast that we need, okay? Don't forget, Forecast systems run every day and consume computer resources, so they should make sense to continue to run for a long time. Next, please. Finally, we have our simple viewer that allows the user to look at results, zoom in, zoom out, see maps, see time series, probe on the results of the model just by clicking on the screen, and see the comparison between EMOGNET and model results, and also from remote sensing from Sentinel-2, our own image processing script that allows the user to see how it fares the simulation compared with the remote sensing data. And all of this is available for the user to see their own forecast. So privacy of forecast is also assured through the registration procedure, which we are going to talk later. Next, please. Okay, forecast systems are very important and we need them for our daily tasks, but there are new tools nowadays that can help the user in a better way and can allow the user to have a richer experience by interacting with the digital part. And those are the coastal digital twins. And how are coastal digital twins going to help us? First of all, they need a set of properties. They need to be based on local forecast and include the early warning part. They should be based on relocatable, meaning applicable anywhere in the world, and customizable tools that the users can build to their own interest. They should be connected with the global and regional data providers and forcing conditions. When you look at spatial scales of the order of 1 meter, like we do at the coast, and a few minutes of time scales, we need to be able to link with the global and regional efforts, like the ocean digital twins. So it's very important to have all those pieces and connections in place. Then we need to combine models, in situ and remote observation in order to build products that are not only based on data, not only based on models, but are based on the combination of both. And the richness of that information that can really make the difference. Finally, and most importantly, coastal digital twins can only be useful if they are designed and built with the end users. It's not only just for the end users, it's to build that with them. So what we have in the end is a tool, an interactive tool that the users know that fulfills all of their requirements. And again, we need to make sure that our coastal digital twins have tools for the end users to address their own problems, because those problems change in time. The tools need to be prepared for flexibility and capacity to implement, for instance, what-if scenarios. So if we have all of these, next please, we have what we call a user-centered digital twin. So a digital twin, a replica of the reality that interacts with the reality, changes monitoring station locations, for instance, because the sensor is not on the right place. Have the data coming automatically and generate early warnings in real time that allow people to react. Those are two examples of this dual interaction that a coastal digital twin centered in the user needs to comply to. Next, please. Now I'm going to show an example that we built recently to address a lot of concerns from our end users here in Portugal. And that is the Connect Coastal Marine Digital Twin. It integrates model forecast and observations from several sources to provide physical and biogeochemical data and services knowledge on Portuguese aspects. Next, please. First of all, we started by co-designing with the users, and we did that with our colleagues from social science to make sure that we address what they need. And this was done in 3 steps. Step 1, we inquired the needs of the users, both by dedicated interviews and through surveys. Then we processed all of that information, built the twin, and then we had a half of the way intervention with in a workshop where we invited all the end users for that particular system, showed them what we have, and gave them the opportunity to make changes, to make adaptations to what they wanted, and that was not already there. In the end, after implementing all of that, we brought everyone together in a room for a debate between the people that develop and the users to look at how we are going to progress, what we are going to do next, how we are going to fund the continuation of these efforts. Everything that deals with digital implementations need to have a continuous maintenance. New data comes in, so we want the coastal digital twins to be rich and useful in the long term. So this connection with the end users is very important. Next, please. So this is a sequence of projects to develop digital twins. And like I said before, besides the short and long-term projects, we also use these digital twins in the scope of the several directives that our end users need to comply. The Floods Directive, the Water Framework Directive, the Marine Directive, and the recent Basin Water Framework Directive. And we built tailor-made dedicated products to address all of these concerns. And this allows the twin to have a multiple use, a multiple importance, and through that, to be able to make this a long-term initiative. Next, please. Okay, let's look at how we built our digital twin in Connect. So we started, like I presented before, we are high-resolution modeling and forecasting using OPENCoastS. And we did that using directly the OPENCoastS interface. One thing I forgot to mention is that the OPENCoastS interface provides a lot of guidance for users to build good modeling efforts. So we use that directly, and we were able to build very nice operational modeling. Then we linked the local infrastructure for data in Portugal, CoastNet, which has a lot of sensors and access to satellite data already processed for the Portuguese interest. Then, next please. Then we built a WebGIS portal that was dedicated for showing and providing access and interactions to the users. And for that, we use our observatory infrastructure built for data analysis in order to integrate all the information. And all of that was integrated in a seamless way with the proper from the Copernicus Marine Service, which was the funding entity here. Next, please. So all of those building blocks were organized in this architecture that you see on the screen. OPENCoastS is there in the middle, in the blue box. So you can see that it's just a small part of the whole effort. In order to build a coastal digital twin, a lot of components need to be accounted for. And again, there are a lot of need for the computational resources and for the data repositories. All of those pieces make the coastal digital twin, make it available, make it updated every day, and make it to the user needs. As part of the WebGIS portal, there are a lot of services that have been implemented. And these are basic services that we then tailor to what we need. And there we have maps, we have time series, we have automatic calculation of statistic, automatic model observation comparison, and also a lot of indications that again go in the direction of the
Oops.
Yeah, Annabella, we lost you for a few seconds.
to follow up, please.
You are back, yes.
Oh, did you lose me?
Yeah, we lost you for a few seconds when you mentioned
okay.
this.
Well, I was just explaining what WebGIS portal offers. Yeah. Can you do next, please? Okay, so let's look at how we built the model cascade in the particular case of the first Connect project. So we have the downscaling from the physics and the biogeochemistry from Siemens. And then we developed two modeling systems for the Tagus estuaries and for the Mondego. And you can see that how we can go from the large scales to the small scales, making sure that the connection provides the quality needed at the boundary conditions and then inside our domain. Next, please. And then in the second project, we expanded that concept to two other areas in the south of Portugal, which has different forcing conditions and different concerns. Next, please. Okay, now let's look at how we built the twin for the Tagus and users. And since we are going to address both inundation and water quality concerns, we developed two different implementations of OpenCoast, tailored to each of the problems. And by doing this, we are very efficient in terms of getting results fast, and at the same time, we minimize the amount of computational resources that we need. Okay, so we could have a single grid that do everything, but then we need to take more time to produce results, and you'll be creating information in areas that was not necessary. Then we have the link with the Copernicus Marine Service for remote sensing, and we have here an example for the water temperature. And finally, we link with the local monitoring data with in situ sensors. And this combination of information building blocks is then going to be mapped in the web portal. Next, please. Here we have a screen of the entrance point at the WebGIS portal, and you have a very simple summary of everything that is going on in your system. So on the left, you have results from the prediction together with the data at the same time at the predictions. If you look at the little circles in the map, those are information from the in situ sensors. And as time progresses, you keep on comparing with the data. And that is very important. So in a very fast way, the end user knows what is happening and how well we are faring. On the right hand part of the screen, then you see a combination of time series at selected points by the user, because this is configured by the user to whatever variables and whatever locations he or she wants. And you see data from the sensors, data from the remote sensing, and also the predictions of the model. If you look at, for instance, the bottom images, you see a lot of information on the left, all the green dots. That's data, okay? And then we have the timeline, and then on the right part of the screen, you see the prediction. So very synthesized way. Then from this synthetic screen, next please, we go to the detailed products that were built with the end users. So we have the typical maps of the forecasts, and then we have virtual sensors, so the user can, on the fly, click on the screen and build a virtual sensors, virtual time series, and then download them. All of these can be downloaded. So if the user wants to do their own processing outside of the portal, he or she can do it. Then we have the products associated with the comparisons with satellite data. And that is very important because we need to make sure that, well, the model is faring well, not only in specific places in space, but globally over the spatial scales. We have comparison with model performance. So again, data model quality always on top. Indicators for the directives and the reports that I just talked about. Next, please. Okay, a little behind the scenes presentation. All of these that you have seen so far are built with a very complex chain of actions that go from the front end and everything that you see anchored on the basic WMS map server that store the netcdf files from the model, the databases that hold all the information, and all of this is made available and provided by the services that we use from EGI. Next, please. So continuing it behind the scenes, Here are the several services from EGI that we use to build not only OpenCoast, but everything that is related with the WebGIS portal. So we need to use, for instance, EGI check-in to make sure that authentication authorization is properly handled. We use Docker and UDocker to containerize all the information and all the actions within the digital twin. And we use cloud computing, the EGI data transfer. So all of these services that the EGI provided are an important and fundamental part of our backbone, and without them, we cannot offer this service for everyone to use. Next, please. Okay, so how we are going from now? The next steps that we are going to entail have a couple of challenges. First of all, we have been talking about forecast, and we are now moving OpenCoast from forecast to IntCast and to the capacity of integrating what-if scenarios, which is something that our Connect Digital Twin does not have yet, but we'll have in the next few months. And for that, we need to have forcing conditions for climate change scenarios, and we are working on that with the FLAME project from the Coast Predict UNDK program. And also we are going to work better and in a more detailed way to enhance the user interaction, to build the products, and to create shareable outputs. Like I said before, our concept inside OpenCoast is a concept of privacy of the user, of their own products and of their own deployments. And what we want to do next is to create an infrastructure that allows us to share those outputs among several people, if the user that creates them allows it. So by doing that, we hope to make forecast systems and their products available to more people, and also to allow the user to have a better capacity to interact with the information, and to build simple tools, like to build a particle model that runs with specific conditions on top of the circulation. Okay. Now, going back to management, our coastal digital twins are now ready and mature to anchor a consensus building tools. And in order to do that, we are going to build indicators from social sciences that quantify different alternatives and make them available to a suite of people that need to take decisions. So with a number of simple indicators, we hope that we can help the consensus, in particular areas like the TAGOS, where we have many conflicting uses. Okay, going from very complex things to a much challenging environment, which is to build digital twins in Africa. And there the challenge is multifolded. We have less data than we have in Europe or America, but we have a lot of needs, and we need to make sure that we convey our messages, our information to the decision makers at different levels, from the national to local level, in a way that information can be used to take good decisions. So we have now a new project framed in the UN Decade of the Ocean Science, the Project WOLF, where we are working with universities and ONGs in Africa to build a pilot digital twin for water pollution. Next, please. And we want to do a first attempt to build a digital twin that can focus on pollution, which is the main problem in the two areas that we have, one in Nigeria and the other one in Cape Verde. And we want to make it fully open. So we want to open the digital twin in a way that if they want to implement it locally for their own use, they have everything to do it. Or if they want to continue to use what we are building, supported by EGI resources, then they can continue to use it. And in order for that to be true, we need to have two important issues. First, We need to train people and provide all the learning materials and translate OPENCoastS to different languages. We are right now implementing everything that is shown in OPENCoastS in 13 dialects from Nigeria. Next, please. So how can we make it work in places that sometimes has very poor internet connection? So we have to revisit our concept of digital twin to make it simple, fast, and lightweight. And the way, yes, there is, and I forgot to put it. Thank you, Federico. And then I'm going to put a link in the presentation and share it again. Okay, sorry, that was a first issue. Wolf is not the app is not opened yet. We are finalizing it, and then it's going to be evaluated by the end user at the two countries. But you can already look at a little bit behind the scenes with our dissemination side. So Wolf is very simple at several levels, very simple in the way it operates. We want people from the local fisheries to be able to use it as a daily tool. So it's very, very simple to use it. It does not have all the complexity that you saw before in the Tagus estuary digital twin. Okay, very, very simple way to operate and very, very light in terms of the needs for the internet connection. You have to see on the bottom of the image that with just a few clicks, the user can see the data from remote sensing and a similar way that they can look at the results from the model. At the same time, we are going to work with the end users to pre-cook products, again, to be very simple to access. So this is it is a very interesting project and a very interesting way to look at things from a different perspective. Typically, we always go in the direction of building new tools, making things more complex, more richer. And here we want to make sure that they operate well so the users have a good experience. Okay, next, please. So this is just the final part of the acknowledgement from the projects that are funding this effort. I'll more than welcome all of you to send me your opinion on what we are doing. We are developing this for the users, and the users are not only the managers, are also the researchers. We have many people that are using OPENCoastS to develop their thesis. For instance, people from the biology areas that are not so keen on the digital part and building other dynamic models, but they need the other dynamic outputs in order to study their biological processes. So we really would like to have OPENCoastS and the Connect Digital Twin to be examples of tools that can reach more users. And for that, we need your help. So do reach out, make suggestions, suggest collaborations. We are more than open to work with everybody. And that is the end of my presentation. Thank you so much for your attention. And now I will answer any questions you may have. Thank you.
Thank you so much, Annabella. Excellent. It's so impressive, this advanced development for how many years already on this. There are so many interesting tools. I see the big effort behind this. It's very impressive. Yes. Let's see any questions from our participant. Any question I do not see from Q&A box. If you want to ask a question, you can put you can just raise your hand. Any comments also? Anything you want to ask, the experience of developing such a complicated, very science, especially it's a user-driven design. I think it's very important to serve the user's need, and that the direction that the considerations or vision of the development is very, very advanced. And Anyone want to share your thought with Annabella and ask especially her experience of leading this impressive advanced development? Nope. And yes, okay, probably we do not have any question. Okay, with that, probably we can.
Sorry, there is one question
There's one.
in the chat. So Elnaz is asking if there is a website for the viewer itself.
Yes.
Yes, there is. So again, I put the link for the Connect portal, didn't put the link for OpenCoast. If you go to opencoast.lenec.pt, that's the dissemination page, and there's a link to the service. Or if you browse through OpenCoast and LNEC on Google, you will find it. You will need to register, and that was a requirement from the several European projects that we had with EGI, so we can keep track of thank you, how many people are interested in these, and where they come from. So, but we accept all users. It's just a formal procedures, and then you will have some help on the interface, so you can give it a try and explore it with some help. Also, you have on the page that Federico just showed, we have a lot of training recordings there that we have done in the scope of the several EGI projects. And you have dedicated lessons for each part of the tool. And you can, exactly. You can, if you go to dissemination, please. Yeah, there you have a lot of training events, either PowerPoints or the actual recordings of the courses. So you can follow that. But again, if you have any questions, any doubts, feel free to send me an email. Okay, I will reply back. And I hope you have an enjoyable experience with OpenCoast.
Thank you so much. Thank you. Yes, with this, I really think this new development with Africa is challenging. As you mentioned, the data set is not complete. There are lack of resources, so it's a really big challenging. But it's amazing that you go ahead and you help them, and they will be very useful for the researcher there. Okay, any other questions? Thank you for the nice presentation. Yes, that's
Thank you.
Really, yes. Okay. Thank you so much, Annabella. Really, really nice, very, very great presentation. Everything so clear. And we hope to invite you back in our future webinars. And then also today, we thanks to our audience and for their participation. Thanks for Federico behind the scene to help to organize everything smoothly. With this, we close today's webinar, and thanks very much again for everyone to join us. We'll send you the recording and the slides and in our following message. Have a nice day and have a good weekend.